that I don't record. So it is recording. Let's see if I can share my screen. Start the broadcast. And here we go. It should all work. Can you see my screen? Wonderful, Bernardo. That was the question. Screen is visible. And thank you all so much for the really good suggestions. In terms of the muting and things like that. Let's see how many people start with unmuted. So it's 6 people, Bernardo said earlier. No, it was Elizabeth who said 6, I think. So let's see how many start unmuted. That would be really interesting. How is everybody on this gorgeous Friday afternoon? Pretty tired, huh? Welcome to my world. Stressed? Why stressed? Oh, yeah. Sometimes people have 3 to 4 fire alarms per night because some clowns are messing around. Daniel, I can't see what you're consuming, so please do feel free. Yeah, well, at least they don't stink. We had that frequently, that people were too exuberant with hair straighteners, deodorant, or keeping the doors of the showers open. Yeah, because I need my beauty sleep. Absolutely. No, I don't know any jokes. My favorite bug, it's not the one in Google. Or in a program that I write. I don't test attendance, so please do feel free. If you have to go to a lab, why do you have a lab at 3? Are you a bioengineering student? Ah, okay, that explains it. Mind you, it should all be one cloud. So the session is recorded anyway, so. And we have somebody who is not muted. Hello. Yeah, Bernardo, you take count, please. Maybe this is a really this is a really good deterrent. I like that. Name and shame. Public shaming, yes. No, we don't do that. We are nice people, aren't we? We don't shame anyone. Although sometimes you find it very difficult not to. So it's 2 o'clock. We won't start before 5 past. So now is a good time to head over to Moodle and record your attendance, please. Yeah, I mean, when I was Master of Rutherford College, I proposed to have sort of the stocks in the courtyard of Rutherford so that we can lock up all the offenders who were smoking weed in their rooms and things like that. But the university didn't agree with that. The lectures, the recordings should be in the respective module on Moodle. If you are on a desktop, you see on the right-hand side a pane under which it says Kent Player and then recorded sessions. If you are on a mobile device, you have to scroll down right to the bottom to see this Kent Player section. Excellent. No, please don't bring in a saw or carving knives. Campus security confiscating them. So please don't. They have a rather low sense of humor, the lovely colleagues from campus security. Sharp stones might work, yeah. Aha. Have we got 2 out of 6? 3. Oh, cool. 3 out of 6. 4. Okay.
Super.
Uh-huh. And some people just simply don't get it with the muting. Yes. I'm setting up a tent in my office here at home. Ty, can you please mute yourself? Apparently, yes. Well, well, well. What can I say? Okay, let's make a start. So, do you believe that 6 was too optimistic? Too little, exactly, yes. 6 what? No, we have a bet at the moment how many clowns are coming in with their microphones unmuted. Oh yeah, cool. Yes, we get even some feedback. So are we 7 or 8 clowns? Fantastic. Okay, let's get started. There is no there is no reason to get upset about things. It's just simply what it is. Let's not worry about it. So, most wonderful good afternoon, everybody. Please don't forget to record your attendance on Moodle because the lovely colleagues in the bioadmin office said they won't be able to do it. Thanks, Bernardo. Excellent. Thank you for sharing the link. So we are doing dilutions today. And also I will give a quick outline of the practical that we are going to do next week on Monday and Tuesday. And I think I've sent you the link to that. No, bioadmin are not just being lazy. Unfortunately, they are totally understaffed and have other things to do than to record your attendance for you. They have, for example, to organize the timetable. They have to make sure that everything is in place, for example, the assessments, etc. So they have a lot of other things to do. So this is the BI 308 Skills for Bioscientists module, and we are doing dilutions for the time being, or at least for today, because you will need that for the practical next week. And I can tell you that you do not want to join the bioadmin team because the pay is absolutely abysmal. Anyway, let's get started. In the last session, we discussed spectrophotometry a little bit, where I showed you the Beer-Lambert law, where I said absorbance equals concentration times the path length and times the extinction coefficient. I know the practical won't be assessed. Don't worry about that. So let's say we have a concentration of 100 millimolar. The path length is 1 centimeter, and the extinction coefficient, let's say, is 6.82 times 10 to the power of 3 per molar and per centimeter. And I'm not entirely sure what I'm hearing, but it's highly entertaining. And we have another clown who is there. Hello, clown. So can you please calculate the absorbance that we would get with this solution? Can you calculate what do you get for the absorbance if we have these things? It's not 10 to the minus. Oh, wow. So we have a lot of different answers. Okay, let's convert that. 100 millimolar. We can convert that. We can write that as 100 times 10 to the minus 3 times 1 centimeter. Or let's do it with this one here. Molar times 1 centimeter times 6.82 times 10 to the power of 3 per molar and per centimeter. So what we see, first of all, is the molar and the molar to the minus 1, the centimeter and the centimeter 1 cancel each other out. And that's quite reassuring because we know that the absorbance has no unit. Okay? And what we have, 10 to the minus 3 and 10 to the positive 3 cancels out. So we have 100 times 6.82. So we get an absorbance of 682. Oh boy, that is big, isn't it? Can we measure that in our normal spectrophotometer? Absolutely not. We have to do something because we can only measure anything up to an absorbance of 1. Anything else is just absolute and utter nonsense. So we have to do something about it. And what we can do is, of course, we can dilute it. We can dilute our substance. And what we can do is we can make, say, a 1 in 10 dilution. We do a 1 in 10 dilution of our substance. Call this substance here that we have here our 100 millimolar. Let's call that our stock solution. Stock solution. So what does a 1 in 10 dilution actually mean? I take one part and put it into another vessel. And I have some nice sound again. One part, and I add 9 parts of dilutant. So the total amount of parts that I have is 10 parts. So I have 1 in 10. And I would be incredibly grateful if the person who has their microphone open could mute it, please, because this white noise is coming from somebody else. Nine clowns or 9 parts? So we have a 1 in 10 dilution. Or we can also say we dilute we dilute this solution tenfold. Tenfold dilution. Both things mean exactly the same thing. A 1 in 10 dilution or a tenfold dilution is exactly the same. And very often people call both dilution factors. Dilution factors, which is really annoying because people obviously mean different things with that. Tenfold or 1 in 10 dilution. But never mind, we know what we hopefully mean. So we do a 1 in 10 dilution. What do you think would be our new absorbance? So the old absorbance was 682. The new absorbance would be what? $68.2. Yeah, absolutely. So the new absorbance is the old absorbance times the 1 in 10 dilution. So that is 6.82. Right. Can we make, oops. Sorry. I didn't mean to confuse you. It's 68.2. You're absolutely right. Because we've diluted the old one by factor 10, or we multiplied it by the dilution factor 1 in 10, and therefore from 682, 1/10 is 68.2. Does that make sense? Brilliant. Can we measure 68.2? Yeah. Still too thick, the whole thing. We can't measure 68.2. What can we do? It's still too concentrated. Okay, let's dilute it more. Let's dilute it. Somebody said 1 in 100. Okay, let's dilute it 1 in 100. Dilution 1 in 100. How would I do that? I take one part and add how much? Yep, I add 99 parts of dilutant. And just for your information, some terminology alert. Instead of part, the Latin word for part is aliquot. You might hear that very often. Aliquot just simply means a part, well, and I can choose how much this is. Right? So one aliquot, it could be a milliliter, it could be a liter, it could be a microliter. Whatever I choose, I don't specify it. So instead of part, I can say the word aliquot, which just simply sounds nicer. And you spell it as aliquot. A-L-I-Q-U-O-T. So we have taken our 68.2 and diluted it 1 in 100. And what is our new absorbance? Absolutely right. It's 0.682. Can we measure that? Woohoo! We can measure that. Right. So, what have we done? We have taken 682, diluted it 1 in 10, and then diluted that again 1 in 100. This is actually called a serial dilution. Serial dilution. Because we are not doing just one dilution, we're doing a series of dilution. And how much did we actually dilute our 682 so that eventually we get 0.682? What is the dilution factor that we used to go from 682 to 0.682? It's 1,000. Absolutely right. So we did 1 over 10 times 1 over 100 equals 1 over 1,000. So you see, in a serial dilution, the dilution factors multiply. Okay? Does it make sense? So make sure that whenever you do serial dilutions, you multiply the dilution factor. Now, we had 100 millimolar solution at the beginning, and that gave us this up here. What is the concentration of the solution that gives us 0.682? Well, what did we do? We took 100 millimolar solution and diluted it 1 in 1,000. That was our dilution factor, wasn't it? What is the concentration that gives us the absorbance of 0.682? 100 millimolar gave us 682. So we have, when we do that, 100 millimolar times 1 in 1,000 dilution gives us a 0.1 millimolar solution. So a 0.1 millimolar solution gives us an absorbance of 0.682. It's not 0.1 molar. Be careful, you are out by a factor of 1,000. And we need to bring it down to 0.682 because we can't measure anything larger than 1. in a spectrophotometer. Absolutely right, Ty. So our original solution with 100 millimolar was far too concentrated. It would have given us a 682 absorbance, but by diluting it 1,000-fold to 0.1 millimolar, and I can also write this as 0.1 times 10 to the minus 3 molar, or I can write this as 1 times 10 to the minus 4 molar, or I can also write this as 100 micromolar. Then I can dilute it and I can easily measure it. Okay, happy with that? So there is, however, a very simple equation that we can use. What we have done here is we had the problem of we have a stock solution of 100 millimolar. That was our stock solution. And very often we will find ourselves in a position that we have a stock solution, but this stock solution is way too concentrated. And therefore, we want to dilute the stock solution. Dilute the stock solution so that we get a set volume, of what is called a working solution. So, for example, the question could be, we have a stock solution of 100 millimolar, and I want 10 milliliter of 0.1 millimolar solution. How much of the stock solution do I have to use? How much stock solution do I need? So we start with 100 millimolar, and that is what we want to get, 0.1 millimolar. And we want 10 milliliter of that. And somebody is posting the equation here. Now, what is it that we are going to do? Let's draw a scheme of that. So here's our stock solution. And here is our working solution. Okay. This working solution is 10 milliliter, and it has a concentration of 0.1 millimolar. Now, what we can do is we can calculate how many moles do we actually have or want to have in our working solution. That's something that we can do very easily. We can say the number of moles is, we just use this here, 0.1 times 10 to the minus 3 mole per liter. That's the concentration here. The mole is in the right place, and I have to multiply it so that the liter cancels out, times 10 times 10 to the minus 3 liters. That's the 10 milliliter. And that cancels out. And I have 1 times 10 to the minus 6 mole. 0.1 times 10, that gives me 1. 10 to the minus 3 times 10 to the minus 3 gives 1 times 10 to the minus 6 mole. Okay? So this is the amount of moles that I need in my working solution. So I need to pick up 1 times 10 to the minus 6 mole from the stock solution. So what I now need to do is I need to calculate what is the volume of the stock that contains 1 times 10 to the minus 6 mole. And I can do that very easily. I can say I'm looking for the volume, liter. Here I have my 100 millimolar, so that's 100 times 10 to the minus 3 mole per liter. But I need to flip it so that the liters are on top. So liters divided by 100 times 10 to the minus 3. Mole. The liters are in the right place. And I now need to multiply it so that the mole cancel out. And I want 1 times 10 to the minus 6 mole. What I see is this cancels out. And what I've got left is 1 times 10 to the minus 6 divided by 100 times 10 to the minus 3. And that gives me 1 times, what is that? Can somebody do that? That gives me 10 milliliter, 10 microliter, 1 times 10 to the minus 5 liters. Exactly. Or 10 microliter. Now, this was the long version. So what we need to do is we need to pick up 10 microliter from the stock solution and add it to actually 10 milliliters minus 10 microliters. And we have then diluted our stock solution so that we have a 0.1 millimolar working solution. This is the long way. This is the long way to calculate how much of the stock solution we actually need. There is a shorter way, because what we have done is we have said the number of moles in our working solution, number of moles in working solution is the same as the number of moles that we pick up from the stock. And we can use an equation for that. The number of moles is actually given by volume of the stock or of the working solution, volume of working solution times the concentration of the working solution. That's the number of moles in the working solution, equals the volume of the stock solution times the concentration of the stock solution. That's the number of moles from the stock solution. And you have seen this, hopefully, as V1C1 equals V2C2, or C1V1 equals C2V2. That's the short form. And what we want to do is we want to calculate how much of this stock solution, how much volume of the stock solution we actually need. So all we need to do is V2, that's our stock solution that we need, the stock solution, equals C1, that's the concentration of the working solution, times the volume of the working solution, divided by the concentration of the stock solution. Does that make sense? This is an incredibly useful equation if we have a stock solution which is highly concentrated, and we want to make a more diluted solution, and we want a certain volume, then we can use this equation, C1V1 equals C2V2, to calculate how much of the stock solution we need. This is something that we are going to do every single day in the lab, and it will come absolutely natural. The equation says the volume of the stock solution equals the concentration of the working solution times the volume of the working solution divided by the concentration of the stock. Okay, so this was dilutions, and this is something that is really the bread and butter for any bioscientists. Okay? And I think we've got another clown. Okay, so what are you going to do? Yes, the volume was exactly 0.01 milliliter. So what are you going to do in the practical on Monday, Tuesday? I'm trying to go over to the website that I set up for you. Can you see the website? Yeah, is it on the screen? Excellent. So this is the first practical that we are going to do. I think I've sent you the link to it. I did send the link, didn't I? Yeah. Good. So what I really want you to do is over the weekend, I want you to look at this website for the practical. This is a face-to-face practical in the teaching labs. However, I am aware that some people are not doing it as a face-to-face for various reasons. And but I want these people, I want everybody to go through it because there is a lot that we can learn. So I have an introduction, there's the science of it. There is also something that's called before the practical. There are a few things. I want you to look at a revision of the Beer-Lambert law. you are going to use spectrophotometers. And there is a link to how to use spectrophotometers. There's also a pre-practical quiz that tells me whether you have engaged and looked at the stuff in advance. So I would really like you to do this pre-practical quiz before you actually start the experiment. Okay? That's really, really important to me, because what I don't want is that people schlep into the practical, say, I don't know what I'm doing. And if you think that is funny, this happens every single year. So when you come in on either Monday or Tuesday, please check your timetable, check that you are in the right group. Because of this lousy virus, we can't accommodate people going into different groups. So if you have to switch groups, we can't deal with that. I'm sorry. You bring in the things that you need, i.e. pen, your lab book. You all have received a lab book, I assume, and a calculator, because without a calculator, you're pretty screwed. You get written instructions. Okay? You get written instructions, but you can find these instructions also under the instruction tab. I have to say something because I discovered a slight error in the printout, so I will have to tell you something about that, but that should not be too big a problem. The website tells you exactly what you need to do, and because I'm a really nice guy, shameless plug here, because I'm a really nice guy, I have created a set of videos that should help you in the task. So here is the experimental schedule. It's a little bit small, so you probably can't see it on the screen, but you can look at it when you look at the practical. And there are 10 different tasks, and these videos actually cover these tasks and the calculations. And I assume you have been shown how to use pipettes. You actually don't really need to make notes in the lab book before, but of course, if you want to make notes, bring them in on a piece of paper or something like that. So that shouldn't be a problem. And you've learned how to use pipettes. You can, if you really want to, you can bring in a tablet or a mobile phone or something like that, where you can actually access these videos so that you can use them during the practical and they can guide you through what you are supposed to do. I want all students to do the pre-lab quiz and also then the final write-up, the quiz after the practical, because there is great learning opportunity. I don't think we will in any way mark it, but we want you obviously to engage with it, and that shows us that you have done it. This write-up quiz, that is actually a replacement for the traditional write-up that we used to do, which students found totally arduous. You can keep your phone out, absolutely fine, not a problem. And you would usually write your calculations in your lab book. And Rosalind just posted the link. The link is also on Moodle, and I will post it again in an announcement. These quizzes are actually not terribly difficult, and I really want you to do them because you learn a lot from these things, from these practice quizzes. Okay? Do you think you can do that? I will check what we do with people who haven't received a lab book. And yes, you can redo the quizzes. You get immediate feedback which questions you got wrong. And I think from a good student, I actually would expect that they do the quiz until they get it right. Because you see which questions you struggled with. So somebody told me once, and I love that phrase, and I will check out what we do with people who don't have a lab book. You all need to have done the lab induction, the safety test, and I think that is also on Moodle. The quote that I really like is, there is no failure, there is only feedback, right? I want students to fail because they learn something, but the most important thing is really that you look at the feedback and really learn something, because that's what you're there for, isn't it? So there was another question, and which I need to where was that? Prepare to fail. The lab, we have demonstrators in the lab who will be able to help you if if you are struggling. And somebody asked if I will be there, and the answer is unfortunately yes. Unfortunately, because it is, yeah, it's 2 days that I will do the practicals, and probably after the first day, you just feel a little bit tired. Yeah, and you will see the clapper in live, in color, in Technicolor, and full size. Okay, so please make sure you arrive on time to the lab session that you have been allocated to. You find that in your timetable. When you come in, go to the locker room, get changed. If you don't have a notebook, I will try to find out what we are doing in this case. And then you should go to your lab station, which has been allocated to you. And if in doubt, ask one of my demonstrator colleagues. You will find instructions there. You have looked at the instructions already, so you are good to go. Get going. I want you to be out as quickly as possible, because then we can minimize the risk in the labs. Does that make sense? Are you happy with that arrangement? I tell you what, in this case, we call it an afternoon for BI 308. If you've got any questions, send me an email or post something on the Moodle forum if you like, but be on the safe side, send me an email and I will try to sort everything out. Okay? And then for those of you who are doing BI 300, I shall see you at, when is it? 5 p.m. for BI 300. Enjoy your coffee afternoon break or your nap, and see you later. Take care. Bye-bye.